All right, we're going to start looking into pressure a little bit more than we did in the last video. And there are three factors that can cause atmospheric pressure to change. The first is temperature. The second is moisture. And the third is altitude. So the first thing we're going to look at is temperature. So as the temperature increases, the air molecules that are kind of far apart to start becoming farther apart. They increase in speed and move farther apart. As they do this, the pressure on the ground decreases. So the air pressure decreases because the same amount of air is taking up more and more space, making it less dense. So it could be like right here, but then if it stretches out a little bit further, it's less dense. There's less compactness to it. So as an indirect relationship, as the pressure goes up, the temperature will go down. As the temperature decreases, the pressure decreases, temperature increases. As the pressure increases, temperature decreases. And when you look at moisture, as humidity increases, as we add more and more water to the air, it replaces the heavier elements like nitrogen, which has two of them together, carbon dioxide, and oxygen, which has two of them together, making the air less dense, and it exerts less pressure. So less dense means less pressure with the air. So normal air looks like this. As I start to add in my water molecules, they'll start replacing in this case, the gray and the orange, which are more dense, with less dense material, which is the water, creating a less dense atmosphere. So again, this is going to be an indirect relationship. As the pressure goes up, the water vapor decreases. As the pressure goes down, we have more humidity. So with more humidity, less pressure. Less humidity, more pressure. And again, with altitude, we're going to see the same type of relationship. As the altitude increases, there's less atmosphere, there's less of it above, and therefore there's less pressure. Basically, the air above you is less dense than the air below you. If you don't remember this, look to page 14. On page 14, you have this diagram, and it is inverted. You can see that as you go up in the atmosphere, it will decrease. Again, I really want to stress, look at the bottom where it has 0 over here and 1 over here, and those are atmospheres. As you decrease, or as you come down in the atmosphere closer to the surface, you have an increase in pressure. And that's because the less dense air, the less pressure it exerts. All right. With pressure, we're going to have a pressure field map. So we've seen the temperature maps, we've seen the contour maps. Now we're going to start seeing pressure maps. How do we know it's pressure maps? Looking at if you see 9.9 or 10.0 or 10.3 or something like that, that we definitely know that's going to be a pressure field map. All right. So these are isobars. These lines are called isobars because if you remember on page 13, one of the pressures that we measure is in millibars. Millibars, isobars, these are lines that connect equal air pressures. So if I have an air pressure of 1000.0, all of the 1000.0s are going to be connected to that line. I cannot connect 1001 to that line because that is not matching. It has to be the same exact pressure. one of the things you might notice on a pressure map, and this is pretty much universal, all the intervals are a 4 millibar difference. And on weather maps, barometric pressure is represented, on weather maps, which we just saw, you're going to see the millibars on that. But when we look at weather stations, pretty much all of them only have a 3-digit number located in the upper right-hand corner of the circle. What I'm talking about is at the bottom of page 13, we have these station models. So on a regular weather map that shows station models, not the isobars that we just saw, but the station models, we're going to see something like this thing. And with the station model, right there in that corner, that is going to be a 3-digit code for a pressure. If you don't know, if you forget, on the explanation, it does say right here barometric pressure, and it even gives you a hint as to the pressure on there. So each of those circles, when you see one of those circles, it represents a city, and usually it'll tell you the name of the city on a weather map. And it's called a station model. These circles are called a station model, and we're going to see a bunch of them. So they're going to be this circle, and you're going to have the 3-digit code. There are rules to these 3-digit codes. So the first thing we're going to do is we have that, say we have a map like we just saw on the previous slide. And the map on the previous slide had, we're going to use the same example I used earlier with the isobar lines. So we're going to have this right here. This is going to be my millibars, 1,000. The first rule when we are looking at these is you have to remove the decimal between the last 2 digits on the right. So I'm going to remove that decimal. So this is going to be step 1. Now that I've done that, it now looks like that. Step 2, the number 9 or 10 at the front of the number is going to be removed. So step 2, I'm going to remove the 10 from the front because this one had a 10 in the front. So I remove the 10 right here, and I'm left with 3 numbers. And this is how you get that 3-digit number. So if I have 000, it's going to represent 1,000 millibars. Now that is to go the direct way just to get the 3-digit code. Now to get back from the 3-digit code, I have to do the reverse. So say I have a 3-digit number, like 053. I have to do the reverse of what I just did, but I have rules to that too. So if it is 500 and above, like 500, 600, 700, like if it was right there, I would have to put a 9 in the front and then add a decimal in between the last 2 numbers. So using that number that we see right there, except I'm going to do 653, right like that, 653. It's above 500, so I'm going to put a 9 in front of it. And then I'm going to add a decimal in between the last 3 numbers, right like that. That's how I would do anything above a 500. Now let's use this number right here. Because it's below 500, I have to add a 10. It wants to be more, because it's less, it wants to be more than that 500. So I start with 053, right? Sorry. I'm going to add a 10 in front of it. So I'm going to add a 10 in front of those 3 numbers. And now my next step is add a decimal in between the last 2 numbers. So I have 1,005.3 millibars. That is how you are going to encode and decode pressures. So let's start looking at this. Let's see if we can do this real nice and easy. So convert to a 3-digit code so we can follow the steps. So the first step is I'm going to get rid of the decimal. So I'm going to get rid of it right like that. So I have 10,030. Then I'm going to get rid of that 10, and I'm going to be left with the 3 numbers. Now here's my little trick on this. This is how I can go real quick. All I'm going to write is the last 3 numbers. So that's a trick after using the steps. It's the same process, only I figure it's a little bit faster and it works a lot better for me. So if it works for you, use it or follow the steps that I showed you. So I'm going to take the last 3 numbers without the decimal. 082. Last 3 numbers without the decimal. 684. It is the same whether it is a 10 or 9 in the front. Use the last 3 numbers, no decimal. 21.6, 72.0, 16.8. This is where it's a little tricky. If there's no decimal, you have to act as if there's a decimal and add that 0 at the end. So this is not going to be just 981. It's going to be 981.0. So I'm going to take the last 3 numbers, which is 810. 681, 32.0, and 009. Real easy. All right, we're going to go backwards. So we've got 040. It is less than 500, so I have to put a 10 in the front. So it's going to be 10.04. Add the decimal between the last 2 numbers. So 10.04 decimal between the last 2 numbers. I have no cheat or easy workaround like I did on this side. I just have to remember, is it less than 5 or more than 5? 1 is less than 5, so add a 10 to the front, put a decimal between the last 2. 0, 10 to the front, decimal between the last 2. 6, it is more than 5, so not a 10, I'm going to put a 9 in front, so it's going to be 968.4. It's above a 5, 982.3. It's less than a 5. I'm going to put a 10 in front, decimal between the last 2. So it's 1032.1. Less than 5, 1021.7. Over 5, 972.3. Oh, sorry about that one. And then above, 1005.8. And above, below a 5, 1016.4. All right, so that is it for right now. If you have any questions, don't hesitate to ask, and I hope you guys have a great day.